We start with number 2. Number 2. We'll get there.
I want you to not have fun tomorrow, therefore I get to win. No, he gets drunk and if he keeps losing. What? Because he basically like and like you did that. It's just like a cycle.
Okay, so I think this might be one of the more difficult ones to integrate. We have dy dx equals cosine squared y sine x. Dy dx, that's equal to cosine squared y sine x. Perfect. Okay, first thing we're supposed to do is separate our variables. And I think there's a multiplication and division. Try not to insult your algebra too much. That's dy over cosine squared y. That's equal to sine x dx. Not quite ready to integrate yet. That 1 over cosine squared y is a disguised secant squared y. Thank you. And that's really advantageous for us because actually there is an antiderivative for secant. Antiderivative of secant squared, sorry, it's tangent, right? So tangent dy, tangent y is equal to negative cosine plus constant, sure. And now this is the part where we have to talk about inverse functions. So if we take the inverse tangent of the tangent of y, we would take the inverse tangent of c minus cosine x. Now, why would we want to do that? Well, we want to solve for y. So the inverse tangent of the tangent of y is just y. And I don't think we don't have an initial condition, right? So that's it, we're done. Inverse tangent of the tangent is just the angle, right? This is where you're very happy you did really well in pre-calculus. Okay. Any questions with number 2?
So if it was instead of the tangent, it was cosine, could we do inverse cosine?
Mm-hmm. Okay. So if you have the cosine of t, the inverse cosine of the cosine of t is just t. Like that. That's the way it works. Okay. If there are no more questions, we'll move on. Let's take a look at number 3. Newton's law of cooling. The instant the cake is taken out of the oven, its temperature is 380. I believe they're telling you T naught there, right? So T naught is 380. And that better be Fahrenheit. Okay, good. After 10 minutes, the temperature is 250. So the temperature at 10 minutes is 250. I don't even know if that's realistic, by the way. Room temperature is 75. Is that, did we write that as TS or TA? I don't remember.
Yes.
TS. TS is 75. And that's everything we need. The question comes after this. How much longer will it take to get to 90 degrees Fahrenheit? Okay. We want to know about 90 degrees. Well, before we can get there, we'll need our equation. So let's get to our equation. Newton's law of cooling says the temperature differential, or the temperature difference, is exponential. So T minus TS equals the initial temperature difference, e to the negative KT. And I'm sorry, I shouldn't have put TS there. TS is 75. Okay, that means the temperature is equal to 75 plus, is that 305? E to the negative KT. Once you have that equation, you can just use your one piece of information, which is right here. That piece of information right there is going to help me out. T10 why did I do that? The temperature after 10 minutes equals 75 plus 305 e to the negative 10K. And allegedly that's equal to 250. So we can do a few things to solve here. First thing is probably to subtract 75. And I believe you get 175. Let me know if I'm wrong on any of this. My arithmetic game's not that great. E to the negative 10K equals 175 over 305. Negative 10K equals the natural log of 175 over 305. And then finally, K equals negative 1/10 natural log of 175 over 305. Notice I'm not reducing. You will never get any points from me for reducing. Don't even bother unless you really have to. Okay? I'd hate for you to reduce it wrong here and then get the whole problem wrong. That would be horrible. Okay, let's do this on my calculator. We have, where's my calculator? There we go. We have -1/10. Natural log of, is that 175 out of 305? And then I want to store that value as k. Now I can use k. Actually, you know what? There we go. Let's screenshot that, okay? Okay. Okay, you don't actually have to write down that number. This right here is sufficient. You would never have to write more than that. I don't even really care what the decimal approximation is. Okay? Okay, so we want to know, when is the temperature going to be 75 degrees? 90 degrees? Okay. So when is the temperature, which by the way equals, now I forgot, 75 plus 305 e to the negative kt. When is that going to be equal to 90? So now we're just going to solve for t. Let's see, 90 minus 75 is 15, I think. E to the negative kt equals 15 on 305. Negative kt equals the log of 15 on 305. And so t equals -1 over k log of 15 over 305. And that's nice because you can just put that in your calculator the way it's written. Okay. So we got -1 over k natural log of 15 over 305. And that gives me the answer, 54.222. But wait, there's more. Okay, here's my but wait, there's more. That gives me, we're supposed to round to the nearest 5 minutes. Well, let's not round just yet. So t is going to be equal to, it's going to happen when t is 54.223. But the question is, how much more time? How much longer? That's the question. Right now, we're sitting at t equals 10. Okay. So it's going to be 54.223 minus those 10 minutes. It's going to be 44 minutes longer. That's to round to the nearest 5 minutes. Okay, so are we close? Are we closer to 55 minutes or are we closer to 50 minutes? I'm sorry, are we closer to 45 minutes or are we closer to 40 minutes? We're closest to 45 minutes. So the answer is 45 minutes. Actually, if you're nervous about that, approximately 45 minutes. Why did I just write that again? After 45, so it'll take approximately 45 more minutes. Any questions on 3? No? Let's check and make sure we're still recording. We're still recording. Question 4. So really, no more questions on number 3? You all figured it?
Can you repeat again why you subtract by 10?
Because we're already at t equals 10, and we want to know how many more minutes. So the cake is going to cool to 90 degrees 54 minutes after it's taken out of the oven. We've already waited 10 minutes, so we have to wait for 44 more minutes. Decay equation is y equals y naught e to the negative 0.16. T. What is the half-life of the element? It's a good question. When is half-life? Half-life happens when the population is half of the initial, right? So basically what we're saying is half of y naught is going to be equal to your equation. Okay. Y naughts cancel, you'll get 1/2 equals e to the negative 0.16 t, right? Natural log both sides. Divide both sides by negative 0.16. And you'll get the natural log of 1/2 on negative 0.16 is equal to t. So just calculator that. Yeah, 4.332 years. So half-life 4.332 years. Hmm?
Was the rate given in the problem?
The rate was not given at the problem. They gave you the equation instead.
Oh, but like the subscript, the exponent. Okay.
Yeah, the exponent was given. Okay, part B. How long will it take for the element to decay to 66% of the original amount? It's pretty much the same problem, isn't it? Okay, except for we're going to do 0.66, why not? Instead of y, 1/2 of why not? So I'll just go through this really briefly. 0.66 equals e to the negative 0.16t. Natural log of 0.66 equals negative 0.16t. Finally, t will be equal to log of 0.66 on negative 0.16. Again, it's pretty much the same problem. Only we're not using half-life this time. I'm getting 2.5969. Bless you. After a there we go. Any questions on? I forgot what number we're on. 4. Yeah.
So do we have to write out like element will be at 66? Yeah.
If it's free response, I would prefer you write that out so you're not being vague. Especially if you know what you're writing. Or if you know exactly what you're doing, write out what the answer is. Where?
Like after
Here?
element will be at 66% after about.
Well, I mean, if we're doing everything with full decimal places, you know, if it's exactly at 3 decimal places, then you can say, you don't have to say approximately anymore.
But if it keeps on, I don't
The AP rules are after 3 decimal places, it's the same number.
Okay.
So this, as far as the AP rules are concerned, this is exact. No, if you put approximately, I wouldn't mark you wrong with that. That's peanuts. I don't mind. Okay, doing well. We're looking at number 5, right? Should I check, make sure we're recording?
Yep.
Looks pretty good. Looks pretty good.
Do you know what happened last time?
Nope. I'm guessing the school network said you're done. Okay, number 5. We're going to use Newton's law of cooling, T naught equal to 190 TS. You can read all of that. First thing is to find the value of K. And you know, really, this question 5 is the same thing as question 3. All the same skills. So you have T minus TS equals T naught minus TS e to the negative KT. Start substituting your constants. T minus TS of 72 equals T naught, which is 190, minus 72, e to the negative KT. Let's put in the next piece of information. Let me put this in a, well, no. Let's underline that for now. We know at T equals 12, we get 120. We can go ahead and solve that now. Let's see, this is 28 plus 20, so 48. This is 118. Again, I don't need the decimal. This is perfectly good for me. You don't need to simplify it. You don't need to reduce it. This is good.
So in our answer, you prefer that we write it that way?
Yeah. You can write it this way if you like. If you want to put the decimal, I'm not going to complain.
We won't be deducted.
Yeah, unless you write the decimal wrong. Okay. Well, I think we're going to need that number eventually, so we should probably figure that out. What do we have? I forgot what it was. Negative 112?
48.
Oh, no, no. Did I get that right?
Yes.
Store is K.
48 over 118.
118? Yeah. Good idea just to always store it.
Oh, search. Search got it.
Is that the name of the pizza?
I don't know.
I know. I think Serge got the pizza.
Oh. Stupid Surge.
Oh, I get it. I get it.
That's why Nathaniel laughed.
I get it.
Wait, say something.
All right, so that's my value of K. B, what is the temperature when T equals 25? Well, that's great. I should probably plug it in. I have a computer on a timer so it doesn't keep charging past 100%. Yeah. It costs $7 to buy a timer, and it's going to save my battery. I was twisting the timer.
I know, but how did you know that it was like,
It was on screen.
Sorry.
I felt it. My calculator. Part B. T minus 72 equals, I don't know, 118 e to the 25k. T equals 72 plus 118 e to the negative 25k. So liberating to be able to type k into the calculator like this. 90.115 degrees. Oops.
You have to specify what degrees.
Only fast. That's a general rule of thumb, by the way. If you only have to really worry about units if someone asks you about units. Well, no, in calculus, only if someone asks you. Otherwise, no one really cares. Part C. When will the temperature be 85 degrees? So 85 minus 72 equals 118 e to the negative kt. Do some solving. What is that? 8 plus 5 is 13. Bless you. Negative kt. (13 on 118) is negative kt. Same solving that we've been doing all chapter. And so t is going to be negative 1 over k, natural log of 13 over 118. Again, you could just leave that, but we'll solve that out anyways. Negative 1 over k. What happened? I think I crashed. Does it look like it crashed to you? That's just a calculator. Yeah, just a calculator.
29.426.
What did you say, 29.426?
Yeah.
And I think these are minutes, right?
Yes. Yeah, it doesn't want to do anything.
Now it won't close.
Yeah.
When you use Task Manager, do you say die right before you close an app? When you use Task Manager, you want to close something, do you ever say die right before you close it? No.
Do you ever notice that when everything starts working?
Yeah.
I turn on Task Manager, everything starts working.
It's because it's freeing up all your RAM. Wait, I should check if it's still recording. Yeah, it's still working.
So about K,
Mm-hmm.
I noticed that it's not always negative.
Oh, come on.
So for, I don't know what first, but it was like, is it kind of like you have to know, you have to read the questions, like when it's cooling, then you know that K will be negative?
It's not so much that K is going to be negative, it's the exponent is going to be negative. So you got to do what you can so that the exponent is negative. Decrease means e to a negative number. Increase means e to a positive number. Okay, so I think we should go to 6. This says non-calculator suspiciously. Okay, point A is a partial fraction decomposition, no problem. 5 over might as well factor that, right? It's t minus 5, t plus 2. Yeah, that's going to be equal to a over t minus 5 plus b over t plus 2. I always like to write out that first line so I get the coefficients of the correct partial fraction. We're going to take the LCD and equate the numerators all in one step. If you need to do that slower, that's totally up to you. We're going to pick our convenient values of t. I think the first one's 5, right? So a equals, no, 5 equals a times 7, b times 0. Therefore, a equals 5/7. Second convenient number is -2. So 5 equals a times 0 plus b times -7. Therefore, b is -5/7. Part A is just a partial fraction decomposition. Ooh. Partial fraction decomposition is five over t minus 5 t plus 2 equals, what's that, 5/7 over t minus 5 minus 5/7 over t plus 2. You know what, I'm surprised, whenever we do this, nobody ever questions the fact that I have a fraction on top of a fraction. Even though-
Then the solution is right.
Even though all year I've been saying no compound fraction.
Yeah.
That looks right.
Every other time, it's just how it is, it just looks right.
Because like you can't break up like the whole
Like, why would
like
you
constant
7
A.
to a bar? Yeah, there's no other. There's no other way.
It could be 5/7 multiplied by 1 over t minus 5. No,
That makes it look
that's ugly.
This is like all complex to make both.
Okay. I mean, obviously I'm not gonna start marking you wrong now.
You should just put a decimal at this point.
If that's a multiple choice question, would it be like that on the test?
Not necessarily.
Like you would actually want to do the decimal or?
Not necessarily. It probably would not be a decimal. It would be like I was saying before, 5/7 over, 5/7 multiplied by 1 over t minus 5.
Like on FRQ, you just leave it at that.
FRQ, yeah. This isn't a final answer yet, so it doesn't really matter. Although on part A, that is a final answer. So. Part B, find the antiderivative of CT. Cool. If you look over here, like, it tells you what tools are being used, but when you use that tool, sometimes it doesn't turn off. Oh yeah, now you turn off. See? Never mind. Antiderivative of CT. That's equal to the antiderivative of 5 over t squared minus 3t minus 10 dt, which equals the antiderivative of 5/7 on t minus 5 minus 5/7 on t plus 2 dt. Do a quick check with the u substitutions. Remember, this is where you could get in a lot of trouble. This one, u equals t minus 5 and du equals dt, no problem. As long as du equals dt, you have no problem. Okay? So this first one, 5/7 natural log of t minus 5. The second partial fraction, u would be t plus 2. du would be equal to dt. Since du is equal to dt, you'll have no problem. You can just go ahead and do it. Minus 5/7 natural log of t plus 2 plus constant. And we're ready for the final answer. Antiderivative of ct dt equals 5/7 the natural log of t minus 5 on t plus 2. Cool.
You just factored out the negative.
Factored out the negative
Like where the negative 5/7.
here.
It's the
Yeah,
log
because
of-
it's the denominator. Last part, let's find our average value of CT from 0 to 1. Average value. Ooh, I hope you didn't forget about average value. The average value, that's going to be equal to 1 over 1 minus 0